Hey, FYI, this is a calculator question. Number 3. A particle moves along a straight line so that its velocity after t seconds is given by v of t equals 1.4 to the t power minus 2.7 for 0 between 0 and 5. Find when the particle is at rest. So we know that the particle is at rest when v of t is equal to 0. So let's go ahead and set v of t, which they so conveniently gave us, equal to 0. And then this is a calculator question, so you could always, of course, just write and then graphed and found point of intersection or something like that, or graphed and found where that happened. But I think it would be a good little review of logs and stuff to solve this by hand. So let's go ahead and solve this by hand. So now I have my variable up in the exponent. In order to get that variable down, I'm going to use logarithm laws to drop that exponent down in front as a coefficient. Okay, so I'm going to ln both sides, and I am going to get t times the ln of 1.4, and that's going to be equal to the ln of 2.7. So I want to get t by itself. And I would get t is equal to, and then I would just put ln of 2.7 divided by the ln of 1.4 into my calculator, and I would get 2.95 in seconds, right? Yep, seconds. Okay. Could you have just done it on the calculator and wrote out what you did? Yes. Did we want to practice doing these by hand? Yes. Okay, 3b. Find the acceleration of the particle when t equals 2. Okay, so what we're going to do now is plug this into our calculator. All right, so I've got 1.4 to the power of x minus 2.7. Little graphy poo, here we go. And then now what I'm going to want to do is it says find the acceleration of the particle when t equals 2. I'm given the velocity, right? And I know that the relationship in kinematics is the derivative of the velocity is the acceleration. I do not want to take the derivative of this guy by hand, but I can do it in my calculator really quickly, okay? So what we would do here is go to home. Remember that this has been stored as variable f3. So let's go back to our calculator page, okay? And I'm just going to go to menu, 4, and numerical derivative at a point. Okay, so we want to find the derivative of f3 when time is equal to 2. We don't want to actually calculate the derivative, right? We just want the computer to, or the calculator to do it for us. So we go menu for 1, okay? And the value that we're evaluating it is 2. We hit okay. And then here's where we put the stored variable, f3 of x. Okay. All right, and we have the acceleration when time is equal to 2 is 0.659. So let's go ahead and put that in our thing here, right? What should we say? Let's see. We took dx of v of x. We evaluate it when t is equal to 2. And we don't need to write we, sorry. And got a of 2 is equal to 0.659 meters per second squared. Okay. All right. So I guess we should change those x's to t's because our calculator doesn't use x's. Doesn't use t's unless we want to work with a slider, but we want to make sure that all of our notation matches for IB. 3C, find the total distance traveled by the particle. Total distance traveled, and we get to use our calculator. Hooray. We have to figure out the bounds, okay? So we know that we're starting when time is equal to 0, and then when does it end? The interval ends at time equals 5. So that's going to be our upper bound. And then we know that total distance traveled is going to be the absolute value of the integral of v of t. So v of t, where is he? He is given as 1.4 to the t minus 2.7. So I've got 1.4 to the t minus 2.7. Okay. And then I would just put this in my calculator and I would get 5.35 meters.